So, here is one of the problems. The square root of y to the 8th over x to the 7th. Now, we covered this a little bit when we did imaginary numbers. And we couldn't have an I on the bottom, remember? And we had to get rid of the I on the bottom. Sometimes we multiplied by I. Sometimes we multiplied by a conjugate, things like that. Don't really expect you to remember all that, but maybe it'll help you a little bit as we do this. Okay, so when you have a fraction under a root, you can't have that. You can't present that as a final answer. So then what you do is you give the top and the bottom its own root, just like we did when we were working with imaginaries. But you can't do that either. But this helps us get to the solution. All right, so we have square root of y to the 8th on top, square root of x to the 7th on the bottom. If I was to simplify the bottom, would the root go away? Why? Because there's a lonely, right? There's a lonely x. You would have 3 pairs and a lonely. So what we need to do is we need to throw something into this problem so there's no lonelies. We need to throw in another x, don't we?
Yeah.
That way, when that happens, now on the bottom you have 8 x's. So, and that's kind of the key to this first topic, is you determining what we're going to throw in to eliminate all of the lonelies on the bottom. Okay. Kind of depends on the index. If it's an index of 3, we need triplets, things like that. It all comes into play. But you have to multiply the top and the bottom by whatever you decide. So on the top, we would get square root of y to the 8th x. And on the bottom, we would get the square root of x to the 8th. Which solves our problem of a root on the bottom. We simplify the top. We should be getting to a point where we can look at that top and see in our head what it simplifies to. Y to the 8th, we'd have 8 y's drawn out. We would circle groups of 2. We would move them out. What's going to happen? You're going to have a y to the 4th on the outside and a lonely x. And then on the bottom, you're going to have 8 x's. You can see I have those written out with 4 groups circled, and those come out to make x to the 4th. All right. And so now we have presented an answer that follows the rules. Okay, so that's the goal in big orange 1 or big yellow 1 or whatever you want to call it. I don't even have them listed here for this section. So we have to throw something into the problem that gets the root off the bottom or gets the fraction out from under the root. Let's do another one. Square root of 2y to the 6th over 5x cubed. To determine what we're going to throw into this problem, remember, we're only looking at the bottom. The top really doesn't matter. It's moot. Doesn't matter. So just looking at the bottom and the potential lonelies that you have for square root, what should we throw in? Can anybody tell?
5.
A 5?
1. 5x.
And an x. You're going to say 5x. You're right. We need a 5 because that 5 is lonely. And we need an x. Because they have 3 x's. And we would have a group and we would have a lonely. Whatever you throw in, once you multiply them together and simplify it on the bottom, now we have 25x to the 4th. There should be no lonelies on the bottom if you did your job. That's what you're trying to do, is eliminate the lonely So there's no root left. On top, the only thing I see is the y to the 6th. 10 has no pairs, and x obviously has no pairs. So the y to the 6th would come out front and become a y to the 3rd. Are you seeing that? And then the bottom, you'd have a pair of 5s and 2 pairs of x's. Look like that.
So you wouldn't take out.
All right, I want you to try this one all by yourself. You should see that we need a 3 and an a because it's square root, so we're looking for pairs. And so we're going to multiply the top and bottom by 3a to give us a pair of 3's and a pair of a's on the bottom, so we end up with 9a squared. The top can also be simplified because 18 has a pair of 3's in it. So the top becomes 3 root 2a. And the bottom becomes 3a. Then the 3's will cancel. The a's will not, because one is in a root and one is not. So your final answer is square root of 2a over a. Now we're going to talk about a cube root. With a cube root, you're looking for triplets on the bottom. So whenever you're going to kick something in to make sure you've got no lonelies on the bottom, you've got to kick in enough so there's 3 of everything. So on the bottom we have a 3, and an x. So what do we need to kick in? Yes, we need to kick in 1 more 3 and 2 more x's. Is everybody seeing this? Everybody understand? So we're going to multiply by a 3 and 2 more x's. Because you need a 3 of a kind for everything, whatever the index is. If the index was 8, you would need 8 of everything. Multiply the top and the bottom. I would get 6x squared, 27x cubed. I don't see any triplets in the top at all. Just looking at that, you should be able to tell that 6x squared is, a 6 is just a 3 and a 2. And then the bottom is what we hope it is, which is 3 3's and 3 x's. And there you go. Try the one on the bottom. All right, in this one, you have 5 y's on the bottom, and you need groups of 4. So it looks like you have a group of 4, and you've got to form another group of 4. So you're going to have to fill that second group. So what you're going to need is 3 more y's. So you're going to have to multiply the top and the bottom by y to the 3rd. That should have been your decision. On the top, we get 4th root of x to the 4th y 3rd. Bottom, 4th root of y to the 8th. The top can simplify because you have enough x's for a group. X, 4th root of y cubed over y squared.